All right, let's look at finding the product here. So we do have fractions, even just normal fractions, right? Like 3/4 times 1/2. Remember, what did you do? You multiplied the top and you multiplied the bottom. Well, the same thing is going to happen here. Is I'm going to multiply the top and I'm going to multiply the bottom. However, if you can do any type of reducing along the way, it is very, very helpful. So I see X. 63 I know can divide by 7, so I can factor out a 7. That's a ugly, but that's a 9, because 9 times 7 is 63. Here I could factor out an X, and that would leave me, oh my pencil's not writing right. That would leave me with an X minus 9. And notice, just as we did with numbers, so let's once again kind of go over here. Let me just give it an example, get rid of this. So let's say that back to our fractions, that I had 4, I don't know, 5th times 10 over 8. The same thing with fractions is, if you remember, you could write 4 as 4 times 2. So that cancels and you have a 2 left. Kind of the same thing here. 5 goes into 10, 2. You can do the same thing here. So I could cancel those and it leaves me left here now with just simply the X times X, which would be X squared. If I can get my pencil back, would be X squared. So that X times that X, and then 7 times 8, which would be 56. So sometimes it's good to simplify these right off the bat, because then they're not so difficult, as you can see here, as my final answer. So let's look at this one. So probably I don't want to multiply all this stuff out. So the first thing that I would do is I would factor these trinomials, every one of them, into my binomials. So I'm going to try to factor every single one of these. And now you can see why the factoring is so important. So I'm going to look at this first one right here. And I know the first term, X squared, the only way to get that, I guess I'll go back to my same color. The only way to get that is X times X. So now I'm looking at this term. What two numbers could I multiply to get 56 and then add to get 15? I think 8 and 7, right? 8 plus 7 is 15, and everything is positive, so that would be positive. Now I'm going to look to factor this. Again, X times X is X squared. Now the issue here is, notice this is negative, but if I had two numbers that I multiply to get 15, and I subtracted to get 2, 5 minus 3, and remember the larger value needs to be positive. Why? Because you want it 5 minus 3 to get the positive 2, and then the positive times a negative to get that negative value. Let's see if I can factor this one. X times X is X squared. There is only one way to get a 3, and that's 3 times 1. Notice this middle piece is negative. So since it's negative, the larger value needs to have the minus sign. This is negative, so a negative and a negative gives me the negative. Finally, my last one, I have X and X. I know I could get 16 with 4 times 4, but is that going to give me a 6? I don't think so. So basically what I'm doing on here is I'm looking at what are the different ways that I could get 16. So how about 2 times 8? And then I could get 4 times 4. But I'm trying to figure out this middle piece right here. What could be multiplied to give me 6? when I'm also multiplying to get 16. And it definitely looks to be the 2 times 8, because 8 minus 2 would give me 6. The 16 is negative, so 1 has to be positive and 1 has to be negative. How do you figure out which one is positive? This value is positive, so the larger number has to be positive. And if you FOILed all these out, but again, this is just really getting factoring down. If you FOILed all this out, then you would see that when you multiply them, you would get these values. Now, the whole point behind all of this is we hope to have stuff like, look at there, look at there. And so it looks like what I have left on top is x plus 7 times x plus 1, and on bottom, x plus 5 and x minus 2. So you can see the whole key is you have to get factoring down.